Hello. In this C programming video, we're going to be going over a basic producer-consumer problem using the concepts of threads and the precedence principle. So as a review here, threads are schedule entities, i.e. they are a resource that hosts a specific job. So in our example here, we're going to have a producer job and a consumer job. An operating system scheduler selects at most one thread to execute on each processor at any point in time. Note, there are three principles in regards to actually scheduling in regards to priority on a priority basis. They are the precedence principle, the preemption principle, and the fairness principle. In this video, we're going to be mainly focusing on the precedence principle as the producer-consumer problem is a perfect example of that. So the program we're going to write here demonstrates how to enforce a precedence constraint. Task B, which we're going to refer to as the consumer, must wait until task A, which we will refer to as the producer, has completed a specific action. This is used, implemented using a mutex for mutual exclusion of the shared data. We'll also be using a condition variable, which we'll get to. The first thing we need to do here is include our libraries. So the first one, our first library here is going to be the standard for standard input-output functions. So that's going to be stdio.h. The next one is going to be the standard POSIX thread library, so pthread.h. The third one is going to be unisted.h, which is for Unix standard functions. And then the fourth one is going to be the standard library. So now that we have our four libraries here, next thing we need to do is to define our shared resources and the synchronization primitives. The first one here is going to be the buffer. So our shared resources and synchronization primitives. The first one here is going to be the buffer. So int buffer, we're just going to call it buffer. We're going to assign that just to be 0. Our second our second item is the mutex. So the mutex is pthread mutex t, and we're going to just call it mutex. Our third variable here is pthread condition t, which is a condition variable. And we're just going to call it condition var. Again, the condition variable is used for synchronized waiting. Threads wait on this variable until a specific condition is met, which is signaled by another thread. And then finally, we're going to define a precedence flag. In other words, a condition. So we're just going to call it int ready to consume. And then we're going to assign this with a value of 0 or false by default. So again, this is the precedence flag or condition variable. Well, the condition specifically. So now that we have our shared resources and synchronization primitives, we're going to move on to the producer thread. So this is going to be task A, which means to set the precedence condition. So the first thing we need to do is declare our function. So we're going to do that using void producer, and then inside we're going to pass void args. Well, we're just going to call it arg. Note, this is, as you've seen in previous videos, this is how we actually define any one of these thread jobs or functions. The first thing we're going to do here is we're going to notify the user that the producer thread is starting work. So to make sure we're labeling things right, I'm just going to refer to this as producer thread, and then I'm going to say we're starting work. Next thing we're going to do here is to simulate the work needed to satisfy the precedence requirement. So, in other words, this is the production time. The consumer might start in block before the sleep, which we're going to use here, finishes. Okay, so again, we're just simulating the work there. Now we are starting the critical section. So inside there, the first thing we're going to be doing here is actually locking the mutex. So we do that with pthread mutex lock, and then inside there we're going to pass the address of the mutex. So that's the first thing we always need to do when we start our critical section, before we start modifying any shared variables. Next we're going to execute the action required for precedence, which is to produce the item. So simply we're going to put something in the buffer, let's just say 42, and then we're going to update the precedence flag. So the condition is now met. So we're going to do that just simply ready to consume. We're going to set that to be 1 or true. Next, we're going to notify the user that we produced an item and that we're setting the flag and signaling. So we're going to do that with printf. Again, we're going to label it with producer thread. And so we're going to say produced item, and then whatever it is. So we're going to use the printf format there. And then we're going to say that we are setting the flag and signaling. Next, we're going to signal the condition variable with pthread condition signal. And then inside the function, we're going to pass the condition variable. Next, once we're all done, we're going to release the lock. So this allows the consumer thread, which has just been woken up, to acquire the lock and exit its wait loop. So simply we do that with pthread mutex unlock, and then we're simply passing in the address of the mutex. And then once that's done, the critical section has ended. Finally, we need to clean up, but first we will notify the user that we're actually finished. So printf, again, producer thread says that finished, and exiting as well. I probably need to put the new line operator here. That would be good. That would be a good thing to do. And then we finish every thread by doing pthread exit and then passing in null. So now we have completed the producer thread. Let's go over it one more time. So simply on line 14, we are notifying the user. on line 15, we are simulating work. And then from lines 19 through 24 is the critical section. So the first thing we do in the critical section is we lock the mutex, and then we execute an action. Then we update the precedence flag. Then we notify the user again. Then we signal the condition variable. And then finally we unlock the mutex. And now once we're done with the critical section, we're going to notify the user again. And then finally we finish off with exiting the thread. So now that we're done with the producer thread, we can move on to our consumer thread. So as you see here, as you're going to see here, we declare it very similar to the producer. So we're going to do void consumer, and then inside we're going to pass in the void argument. So the first thing we're going to do here is we're going to notify the user that we're starting, but we have to wait for the precedence condition to be met. So we're going to do printf, and then we're going to label this as consumer thread starting, but waiting for producer. Next thing we're going to do here is we're going to lock the mutex. So we're going to, again, we're starting the critical section here, so let's label that. So again, the first thing we do, just like the last, just like here, we have to lock the mutex by passing in the address of it. Then the next thing we're going to do is we're going to keep going through a precedence check loop. So the correct pattern for condition variables. The while loop is essential because of spurious wake-ups, otherwise known as waking up without a signal in competition, which means multiple threads waking up. We recheck the condition before processing. So we're going to do while, and then inside here we're going to do ready to consume, because remember that's our flag. While that is equal to 0, otherwise false, we're going to notify the user that it's not ready. And then we're going to say that we are atomically unlocking the mutex and waiting. And then inside here, we're going to use the wait function. So pthread condition wait. And then inside there, we're passing in both our condition variable, and then we're also going to be passing in our mutex, the address of the mutex, rather. So when the ready to consume flag is 1 or true, we can now move on from the while loop, and then we're going to first notify that the user of the precedence is met. So printf consumer thread, the precedence is established, and then condition is met, and then finally consuming item, and then we're going to use the decimal format specifier here, and then we're going to do a new line. But obviously we need to pass in whatever's in the buffer. And then we're going to perform the dependent action, which is consumption. So for this example, we're going to set the buffer to be 0. And then finally, we're going to move on from the critical section by doing what we did with the producer and unlocking the mutex. And then obviously we pass in the address of the mutex. And then we're going to say that the critical section is done. And then finally we wrap up by first off letting the user know that the consumer thread is finished consumption and exiting. And then finally, we do pthread exit and then pass in null. So as a brief review here of the consumer thread, first we are notifying the user that we're starting. We're entering the critical section. So first we lock the mutex, and then we check to first in the while loop. What the while loop is doing is we're checking to see if we are not ready to consume yet. And then inside there, inside the loop, we're notifying the user. And then we are, in the function there, we are waiting on the condition variable. So, in other words, we are releasing releasing the mutex so producer can enter its critical section. But we are also blocking the consumer thread. But once we are ready to consume, we first off notify the user, because at this point the producer has produced the buffer. And then on line 44 here, we're going to just consume. And then we end our critical section by unlocking the mutex. And then we wrap up here in the consumer by notifying the user and finally exiting the thread. So now that we have our producer and consumer done, now we can finally get into our main thread, which sets up and executes both threads. So in our main function, obviously we're going to do an int main. And then the first thing we're going to do is define our producer and consumer thread IDs. So pthread t, for our producer, we're going to call it prod TID, and then consumer in a similar format as well. So we have our two thread IDs. Then we're going to notify the user that we're starting. Main function, rather. And then first thing we need to do here is initialize the mutex and condition variables. So if initialization fails, the program should ideally handle the error, but we omit detailed error checking here for clarity. So we're just going to do if pthread, first we're going to do the mutex, so if pthread mutex initialize, and then we're going to be passing in the address of the mutex, and then null, because we're using default concepts here. If that is not equal to 0, we need to let the user know, so we're going to do p error, and then we're going to pass in an error statement. So main function mutex initialization failed. And I keep forgetting my new line characters. And then we're going to return 1 noting an unsuccessful execution. Next thing we need to do is we need to do a very similar thing with the condition variable. So we're going to do if pthread condition initialization, and then we're going to be passing in the condition variable, and then null. If that is not equal to 0, then we need to do a similar thing here. We're going to use the p error, and we're going to pass in main function condition variable initialization failed, and then similarly we're going to return 1 for an unsuccessful execution. So now that we have initialized our mutex and condition variables, we're going to actually create the threads. So we're going to notify the user that we're creating our consumer thread first. So main function creating consumer thread. And then we're going to use the pthread create function, pthread create, and then we need to pass in our consumer ID. Then we need to pass in our null. Then we need to pass in our consumer, because that's the function name. And then finally, we do null again. Similarly, we're going to create our producer as well. So we're going to do main function, creating producer thread. And then we do pthread create. The first argument is our ID. Note the address of our ID there. Then our attributes, we're using default attributes, so it's going to be null. Then the actual function name, so producer, and then finally null again. Now we can join the threads. So the main thread is going to wait for both the producer and consumer to complete. Pthread join is crucial to prevent the main thread from exiting early, which would terminate the entire process and all running threads. So we're going to do pthread join, and then we're going to be passing in the producer ID as the first argument, and then null as our second argument, and then similarly our consumer ID, and then null as well. And then once that's done, once we get past line 70 onto 71, we know that both threads are completed. So we're going to notify the user. Well, I'm just going to say producer and consumer threads completed. And then we're going to say the final buffer value as well. And we're passing the buffer, obviously. The final thing we need to do is clean up the synchronization primitive. So we're going to destroy both the mutex and condition. So pthread destroy. And then we're just going to be passing in the condition variable. And then we're also going to pass in the pthread mutex destroy. And then we're going to do a similar thing, pass in the address of the mutex. And then now we can notify the user that the program has successfully executed. And then finally, we can return 0 to indicate a successful execution. So again, as a review here, in our main thread, first we are initializing IDs. Then we're notifying the user that we have started. then we are trying to initialize the mutex, but if that doesn't work, we notify the user, and then we return unsuccessful execution. We do the same thing with the condition variable. But if that doesn't work, we notify the user of the failure, and similarly, we return an unsuccessful execution. Then we notify the user that we are creating the consumer thread. And then in a similar format, we notify the user that we're creating the producer thread. Then we are going to be, for both, we're going to be joining threads. And then in the similar format, we're going to join consumer thread. And then we're going to notify the user that all threads have complete execution. And then we're going to do some cleanup. We're going to destroy mutex. And then we're going to destroy condition variable. And then we're going to notify user that we're done. And then finally end the program. So this is a long example, but this is a pretty fundamental concept. So I hope this was informative. Let us run our terminal here. And then we're going to, first, we're going to compile our program here. So we do that with GCC. We need to use our pthread argument here. And then we need to do our file name, producer consumer.c. And then we're going to call it just producer consumer. And then finally, we're going to compile this. Run it. So as you can see here, we were starting. We create our threads. We started but waiting for producer. And then the producer restarted the work. Notice after this line there was a delay. So that was our sleep function up here, actually simulating the work. And then we produced the item. We finished and exited. Note, we consumed the item 42, but at the end of the day, the final buffer value was 0. So the program was successfully executed. I hope this video was informative in understanding both producer-consumer problems and the precedence principle with POSIX Threads. Please like this video if it was informative. Comment with any questions, and subscribe to the channel to get more tutorials like this one. Thank you for your time and watching, and have a great day.